My name is Andrei, and I'll be talking today about the Oniro Project, which is a Yocto-based product-ready distribution. This is the title of the talk, and I'm going to structure this presentation, following this plan. I'm going to first talk about the current state in IoT, the issues, the problems of this domain. How we see open source as being a solution to the problems that we have identified, and we all kind of suffer from it as a consumer, first of all, and not only. And afterwards, we're going to talk about Oniro using core components in its platform, like Yocto Project, for the build infrastructure, and not only architecture of the project, so layers and stuff like that. How do we handle that? What are our plans? What are our plans in terms of releases and roadmaps? What are we working on? What we are planning to work on? Features like CI testing and IP compliance. What do we do on those sides? Blueprints, something I'm going to define. Our approach to MVPs for the platform. A live demo. Yes, I'm that confident that it's going to work. And yes, I'm going to finalize with a couple of conclusions, references, contact, and miscellaneous. Let's see. Boom. Great. So first of all, who is this guy here? His name is Andrei Gherzan. He's working for Huawei in the Open Source Technology Center as a principal open source architect. He's basically doing these three things. He's pushing buttons, and I don't know why my mouse does tricks on me. So he's pushing buttons, he's checking his calendar quite often, and he's browsing the internet. So he has been doing this for more than 10 years, from domains like automotive all the way to IoT, consumer devices, working on the Linux, mostly on the Linux software stack, on mostly all the levels. And yeah, that's basically me. So in terms of the IoT, I experience this situation every other time I want to buy a new gadget. Every time I want to get into a new IoT environment or ecosystem, I get devices, they look great, they seem to satisfy my use cases, and I buy them, and I end up with yet another gateway, yet another application, and so on and so forth, just because the vision of the IoT world is obviously silos. It's fragmentation at its core. And it's impacting our daily life, both because I have to deal with those, and concerns around privacy and security and so on and so forth, not to mention the actual functionality, the fact that these devices cannot talk to each other. So, the fact that the consumer market is fragmented, it trickles issues on multiple aspects. The developers can only have access to their specific ecosystem, to one ecosystem. If I develop an app, I will have to happen in the boundaries of the ecosystem defined. The technologies that are growing in those ecosystems are limited to the same boundaries. So you end up with technology silos. Porting of applications, obviously SDK, and that happens in the same environment. And that hurts the actual functionality of the devices. Communication between devices will not happen. You need to have another layer. You have to have some sort of export to a cloud that has that exports data and then is consumed on another side. So you have to go around these limitations to achieve communication, which has other problems. It has security and privacy issues, to maybe just a few. So what we are saying is that we need common standards. We need common standards so we can empower consumers' daily life. We need things like one single cohesive application, and basic things that we consider basic as interoperability between devices. One broad range ecosystem. Portability, right-wise deploy on multiple devices, on different devices, and on-prem secure data, being able to hold your data on-premise and being able to own that data as you are part of this domain, of this IoT domain. And The main aspect that we consider as a solution to these problems is open source. And I have here three main words, and that is ubiquitous, and that is basically the broad aspect of the platform. We need to tackle devices from small to big on the same platform with the same baseline, so they can end up in a fully interoperable and communicatable world. It needs to be collaborative, and that is the nature of open source. And especially, and I'm going to stress this, is a key to be able to influence requirements, roadmap, and features. Being able to be there in the open, and people being able to contribute to aspects that are core to the platform. And open, being able to download, being able to use, being able to assess. Is just the nature of open source. So the mission that Oniro has is to avoid technology silos through means of open source. And that is by providing a base platform, a baseline that is open, transparent, and collaborative. Right, so open source, again, five elements of the open source that I've mentioned. But I'm going to re-stress them. They have to be all the way on the stack, from hardware all the way to applications. So hardware being hardware freedom and inclusivity, technology, and we are talking about things like distributed virtual device, so we can share resources between virtualized devices. Community, core foundation of the open source software. Implementation, because you have now a dynamic open ecosystem, you can tackle end-to-end implementation. And application in terms of distribution and data management. So in terms of architecture, Oniro uses Yocto Project, and by extension the bitbake build system. We're using the entire all the layers that are basically the pool of the packages in the platform. And it's not a secret anymore that Yocto Project nowadays is the de facto embedded Linux factory, let's call it, the build system of choice for embedded systems, because it's flexible, it's highly customizable, it's cross-kernel operating system friendly, and it provides the ability to just tailor your use case in one unified platform. On the Oniro side, we have defined the project as a couple of layers. From bottom to top, we have a kernel layer, and in this layer we tackle multi-kernel support. So we support off the box right now Linux and Zephyr. We also have experimental support for I was just realizing that I haven't started my timer, so I lost a bit. Okay, I'm 10 minutes in. Great. So we have right now support for Linux and Zephyr. We have experimental support for this now slips my tongue. And we're also working on LightOS. This is an activity as part of the Open Harmony compliance. We are working on another layer. There is a framework layer, which will provide support for SDKs in writing applications in languages like Java, C, C++, and JavaScript. On the system side, we have a system services layer that provides core functionalities to the platform that the framework layer can take advantage of. And the application layer. This will provide the application that will be able to use the APIs exposed by the platform. Great. So in terms of layer setup, we are using obviously our own layers. This brings in functionality in terms of gluing, but also components development for filling the gaps that we find in the domain. We are using Meta Open Embedded as the general pool of recipes, Meta Clang as a toolchain layer. We are using kernel layers like Meta Zephyr, FreeRTOS, that's the one I was missing. So FreeRTOS experimental support, Meta LightOS for the LightOS kernel. We are using layers for Open Harmony compatibility, compliance, and also BSP layers, Seco, ST, AV96, Intel, to name a few, Raspberry Pi as well. In terms of the roadmap, we are currently working on the Goofy release. And I'm going to cherry pick a couple of features that we are focusing on as we speak. So in terms of runtime and tools, we are working on system OTA, both on Zephyr and Linux side. That ties into a end-to-end cloud backend that we are working based on Hawkbit. So this entire stack is based on Hawkbit and Rauk. And we are also looking in components like Canto. If you're familiar with the Bosch project, that's something that they are in the process of open sourcing, and that's going to be interesting to see in terms of telemetry, metrics, and so on, stuff like that, to see how we can hook into that component. We are also looking into kernel LTS support, that is maintenance, security maintenance. On both Linux, Zephyr, but also Light OS, happening later this year. And I think that's all I'm going to say here. On the reference hardware, we support IMX-based boards and x86-based boards from Seco, Raspberry Pi, so ARM-based boards. We support obviously virtualized platform, QEMU-based. On the testing infrastructure, we are aiming by the end of the year to have 4 independent testing labs online, looking as well into vulnerability handling tools, periodic reports of functional and perf verification. On the blueprints, that's something I haven't defined yet, but I'm just going to say that we are going to develop more MVPs on top of the platforms, from smart home assistant based on Mycroft to smart panel to transparent gateway, just to name a few. Standard compliance, we are working into getting Yocto, OpenChain, Open Harmony, Matter, Ledge compatibility of the entire platform. We are also looking into autonomous agency, so components like communication plumbing, virtualized layer. So how do we manage have a POC implementation, or even basically to put in all the primitives that will give you the baseline for virtualized devices. So that is part of the roadmap of this release as well. In terms of releases, we have finalized our first release last year, the Jasmine one. We have a cycle of 1 year development followed by 3 years of support, so LTS, for the LTS releases. The one last year was finalized this year, and the one that we are working on is called Goofy, and it's going to be finalized at the mid of next year. The next one we are working on, so the next after the 2022 one, it's going to be called Daisy, and for people who have been enough around, that's going to ring a bell in the context of Yocto. Great. So in terms of support, we have 3 tiers of support, 3 years. The first year, all bugs and CVEs, all the way to the third year, where we have only P1 bugs and CVEs from 7 to 10, and toolchain CVEs from 9 to 10. Great. So in terms of the features of the platform, we consider that CI, testing, and compliance needs to be baked into the platform. So we upfront provide those as part of the integration. So we have configured GitLab runners. So we have a GitLab instance, GitLab runners that maintains per runner bitbake state and download cache. We also take the CI through scan code, Fossology, reuse. We also develop a tool that does Debian matching license compliance, so we can reuse part of the information from there. As you know, this step usually is quite demanding in terms of resources and time, basically. So being able to reuse existing work is quite important. So that is part of the continuous integration and deployment feature. On the testing side, we are using Lava as a base, decentralized distributed device testing. And that gives us the nice feature of a member being able to contribute their own physical devices while being a different location. So I, as having a Raspberry Pi around, I can hook it to the power and to the platform and be able to use it as part of the CI and testing infrastructure. Each site can have 1 to hundreds of devices. So we provide the ability to have that as a scalable component. In terms of IP and FOSS, we are looking into open chain specification 2.0, do both low resolution SBOM and high resolution. So low resolution as merge scan fossology with a dashboard that you can see on this side of the screen. On the left side of the screen, it's a snippet of it. It's basically providing a visualization of a Yocto project-based build in terms of licenses. The distribution of the types of licenses, at the level of files as well, how much were detected, how much the system was not able to figure out what they are about. It needs manual interaction and so on and so forth. Great. So again, standards, we've been working on Yocto compatible. I'm just going to say that this is ongoing work, is not yet done. We have done that for a layer that we are using, but for the entire platform, we are in the process of doing for the Kirsten release. Also, reuse compliance, ARM system ready, all these things are part of the current load and activities. Great. So blueprints, I've mentioned this a couple of times, and I did say they are minimum viable products. So we basically in the platform create primitives, or we try to compose a platform, a baseline that any product can work on top. And this baseline will contain primitives in terms of, for example, OTA, or as being a core feature, or security management, or I don't know, anything else really. And on top, on the vertical, we are building blueprints, which are basically MVPs that showcase a couple of core features of the platform. And they represent a use case, a real product use case for a specific domain. And while doing so, we select the, intersection, or based on the intersection of hardware support on the domain, so the requirements of the domain in terms of hardware, and what Oniro Project supports as supported platform. So that intersection we consider for the blueprint, and we basically build a vertical on top. We have built already quite a couple of them. We have a door lock blueprint, which is basically a smart door lock system that can control both local key locks, or blocks, and also wireless locks via secure wireless communication. It takes advantage of the secure OTA feature on the platform. Also a gateway blueprint, so that having features in terms of Wi-Fi access point. It includes support for open thread border router. Also the ability to onboard and keep participating a mesh node into the open thread network. And the blueprint that I'm going to focus a bit more is the vending machine blueprint. This is the one that I'm also going to show you as a demo. So this blueprint is basically a POC of a vending machine, a smart vending machine. So it provides the functionality of UX and UI in terms of selecting items, presenting items, and being able to order items. And it emulates the fridge operation, so the control of the actuators, the pumps and whatnot, through a LED matrix. It has support for 2 hardware setups as we speak. It has support right now on Seco x86, an x86 based board, so B68, Seco B68, and Raspberry Pi 4B. You can see a link in the slides. All these slides are also uploaded, so you can reference later. Great. So with that being said, I can go on to the demo time. As I said, I'm going to be adventurous. Oh, and it works. Great. So as I said, we are having here the B68, but the x86 based setup. So there is a SECO B68 board right here, connected over HDMI to a display. Let me turn it on in the meanwhile as well, so you can do it. So HDMI, so DP to HDMI adapter to a HDMI display. Also touchscreen capabilities via USB. And the board, the SECO board, controls via I2C a matrix of LEDs. So it's a 5x5 RGB LEDs, and we emulate different operation both by position of LEDs, so selection, and also by color. So color will show a state. If it's red, it's going to be selected. If it's off, it means it's not selected. If it's blue, it's undergoing the delivery process. So it's it has functionality in terms of selection. Let me before going to that, let me talk about a bit about technologies behind it. So in terms of the applications are developed as a client-server pattern. So we have two applications. One that is meant to run on a microcontroller that controls the fridge, the actuators, in this case the matrix. The other one is an LVGL-based application that controls the UI, providing the UX to the user, and they communicate to each other via WebSockets. So they're meant to be scalable over network and distributed basically. So this implementation right now, both these applications are running on the same board. But as I said, in a real case scenario, that would be another microcontroller that would be on the control side. So as I said, the UI takes advantage of the LVGL framework, graphics framework. We have support for LVGL both on Linux through this showcase through this blueprint, but we also have support for Zephyr, and we have a blueprint for that as well. And that is more of a independent or like flexible UI platform where you can basically define with a configuration the UI elements on a Zephyr based system. That's a different approach. You can find more information on the documentation on that. So yeah, in terms of this specific blueprint, I can select items, I can deselect items, I can buy items, and the color will change, basically showing that they're undergoing the delivery process. And as soon as that is done, the system will just provide a thank you message and reset. Oh, by the way, these wooden loops are my baby girl's contributions to the presentation. To just lay them around. Cool. So getting back to the presentation. Awesome. So I've discussed a bit about Oniro. I've showed you a bit of how Oniro looks in terms of a product, I guess, a level of product we develop. But at the end of the day, it's about you, I guess. It's about me as a consumer. It's about you as a device maker. It's about somebody else as a content creator. What is it really for you? As a consumer, you just end up with devices that are actually providing the smart capabilities that you're aiming at, right? They are going to have fast connection. They are going to have abilities to collaborate between themselves. And they are going to have features that will allow resource sharing. If you're a device maker, you rely on the fact that there will be upper layers that will support your hardware. And those upper layer will be used by the application developers to be hardware agnostic. If you're content creators, that's exactly what it's going to be. As a content creator, you will not have to, you will not end up having a hardware specific implementation, nor a platform or ecosystem specific implementation. You have the same baseline, no matter the capabilities of the hardware, without, I guess, sacrificing any kind of capabilities or service characteristics of the platform. So how to get started. All the layers, the entire infrastructures of code, meta layers, and so on, and code itself for the components that we have developed are on Eclipse Foundation's Eclipse Foundation GitLab instance. So you can download, you can build them. You will find more information on our website. So once you get that, you can use them. I guess you'll probably have to read the documents. I'll probably need to be the other way around. Read the documentation and use them. And if you find that they become, part of your use case, satisfy your use case, contribute, be part of the community, and we would definitely like to hear of you. In terms of communication, you can reach to us via the mailing list, both our Eclipse Foundation mailing list. So there is the working group mailing list, the technical mailing list for the technical discussions, and a channel on LibreChat. Twitter as well can be used in any way. We'll definitely be happy to hear from you.